Forgot to add on to the recording. So now we can actually do stress analysis and show you why it's not the best when it comes to using a fake spring in a simulation. So I can actually go here, click on this little symbol here, simulation, select our mass, pick time 0 to time 1 second. Add the time, select it, click OK. We can run calculations. Ran the calculate, it's going to rerun the whole thing. Rerun it. It's going to calculate each step, so up to 51, so it might take a little bit of time. Alright, we're coming up to the end of our calculations. So let's take a look. It's going to give us a plot of stress, but you'll see that it's only going to plot the force versus the spring and the force. So usually your spring will actually give a reaction force to your mass, but it's not going to be plotted here, so that's a downside of using our springs in our motion analysis versus actually creating springs in SolidWorks to test. But it comes and goes. Like, do you want something quick in analysis, or do you want something more accurate? So design your own springs is a great option. So if I wait here, I'll actually pause it again until it pops up. Okay, so this is our plot. Pretty much industrial only. This is our stress plot. See, we find the most stress around these areas. Deformation plot around the corners. Factor of safety plot. Consistent everywhere. So actually what I predicted was interesting, how it actually showed you how you feel the least amount of force here. But that's because we're just acting on just the weight. There is no actual motor acting right here. So if I rerun it with it, actually. Rerun it. Here we go. Now it shows with the force acting on it, but the spring reaction force isn't being shown at all. So this type of work is great for when you're applying forces or some sort of servo motor to tell you like what reaction it has on it. But for springs, for some reason, it just doesn't show very well at all. So you can get stress, factor of safety. It'll show you factor of safety everywhere should be around a 0.5, because this is very likely to break versus something down here where it'll feel the least amount of stress. The factor of safety should be somewhere around the factor of 1 or something that's not too great. Actually, I'm not sure about factor of safety. That's something I gotta look into, but you can plot a lot of cool things with this. But yep. Overall, so sorry, it was quite long for me. That's how you basically plot out from design all the way to CAD analysis on spring dampening. Usually this is just something super basic, super simple. So as soon as you can get something realistic from initial conditions, you can research online. You can move on to something more complex and get more accurate analysis from. Yeah. Next thing that I kind of want to cover is going over actual design of our plate. So we're trying to map out the inside of our engine bay and then recreate the initial mount designs or supports for the transmission and the motor. And once we have that set, then we can actually start designing something for our motor to make sure that it's in line with the transmission, as well any type of torque reaction force we have, we can counter. So, yep.